Well, this drawing is a lovely little challenge for an isometric. It's got some tricky bits and some nice satisfying bits. So often you'll be given your three orthographic views. All right, load of measurements, load of bits and pieces going on. So first things first, we want this as an isometric, okay, and this actually is going to be a scaled isometric. So we use the isometric scale, and I'm assuming you know what that is in this drawing. So we're going to set up our scale, set up our axes, create it off, and go from there. Right, well, on this side of the page here, we will set up our scale. So just see, there we are. Okay, that's 30 degrees. And then we'll set this guy up. Okay, the biggest length I have in this, if I have a quick look at it, is going to be 90. So actually, I probably got over enthusiastic with my isometric scale, but that will fit in quite nicely. So that's 45 degrees for the true and 30 degrees for scaled. Now, let's put our axes in. So we'll just see, can we squeeze these in nicely here? There we are. Okay, so this should fit in that little bit of a space, and we'll just do a bit of reorganizing to make sure we can see it. Okay, so let's get our different views figured out. Well, as we're looking at this one here, we are going to, this is going to be my front elevation here. And this can be my end. That's usually how we will do it. There is, you can turn it if you have to, if it's more useful. There's not much in it in this drawing. So I'm going to leave it in this orientation. Right, well, scaled 90. And we'll add 11 in a second. So let's see, we need a scaled 90. So let's measure this off. Again, I always like to number these because it saves you going back to them. I can see that it's going to be 80 tall, and adding all those up, 60, 75 across. I want to scribble that stuff down on an exam paper so you can see it. There we go. 75 and 80. So let's get those measurements in, and we'll build up our crate. Now, on a drawing like this, I always like to think about what's my little warning signs when things can go wrong. And this one is, it's not super obvious if you mixed up these ones. Okay, if it was a very long rectangular drawing or something like that, you'd see it if you made a mistake. Here you won't. So we just need to be careful that we set these views up correctly. All right, so we'll just take a little bit more time than I would on some drawings. So we'll double check. The front is 90. Okay, grand, let's get that down. All right, it is, the end elevation is a 75. There it is there. And it's 80 high. Okay, so we'll create this off. Now a little tip is you can rub out the rest of this axis above the highest point because it only kind of gets in the way at the top. So let's see, can we do this? Right, there we go. Now, and see the way we're using this, I'm only measuring these things once each time. We can do the whole thing there. So now we're just going to do a small bit of camera readjustment, get ourselves back on track so we can see everything as we go. Now that's a little bit better. Okay, so remember I said in a drawing like this, I see mistakes looming because of the shape of it if I began to turn things around. And the way I like to approach these things is rather than give myself a clap across the ear if I make a mistake, I will assume I make mistakes and I try to work around them. So what I want to do is I want to get this big triangular section drawn first, because then it'll be really obvious which way this is facing. So I need a 15 and a 10 and then we just connect the dots. So let's go and measure these guys. There's 10 and there's 15. Okay, so we'll scale them. Now 10 is really fiddly and annoying. So for the 10 we're going to measure it, and you'll notice if you do this a bit, 10 scales to actually about 8. Alright, so 10 is, just check, this little one here at the top, so there we are. I don't really want my head to be where the camera is, but that should do us right there. Okay, so make a little mark there. And we need to come up by 15, and this of course we'll do with a compass. And it's worth thinking, if you really hate the little measurements and they're annoying you, of course the other way to do this would have been that was 90. So I could have just used my 80 there, which in hindsight was probably a better idea. But hey, we all get it done in the end. Now, that's a lovely clean face. I'm going to put that in heavy, so it helps me orientate myself in my mind. There we go. You may be far more organized than I am and not make all these silly mistakes, but you know, that to me is my challenge, and I know it's kind of my weakness, and to me, once I know it, it's no big deal. We work around it. Now, what about the angle? Well, whenever we do angles, okay, start to the end. What angle is that? Who knows? You can figure it out pretty easily, but I'm not really bothered. I know where it starts, I know where it ends. I'm going to connect the dots. Okay, and there we go. So now I have that edge in. Okay, this drawing is going to be much harder for me to go wrong at this stage, so this is a good move. Now, what do we do next? Usually I would say begin to pick away at the things that are easiest. All right, so I can see that there's that 10 mil line continues across the top a bit, so we'll stick that in. All right, and the more easy things you get done, the harder stuff begins to get more manageable, and there are some tricky bits in this drawing. Now there's a gap in that, so that's why I've left it as a construction line. Let's see where else we might go. Well, if I came back by whatever that distance is, oh, there it is, 40 mil, okay, and a 15. So actually, I even have my compass set to 15 at the moment for that top one. So I'll use this again. There we go. And then we'll have to do a 40. So let's just solve this 15 for the moment. And I like the ones on top because you know what you can see. You don't have to worry about, is this visible, is it hidden, where is it going to go? These ones are clearly, completely visible. So there's the top. Now we do have to add a 40 in for the other one. There it is. Remember, it doesn't actually matter what order you do these in. Just make your life easy. But if you're trying to figure out where to go next, just pick something that looks manageable and do it. There's my 40. That comes in from there. Again, I'm only doing on one because I can just project it across. Okay, grand. So there's my top two pieces. This is coming together. Well, where will we go next? Well, it's kind of up to you, but again, the next easiest thing that I would see is this L in the end elevation. Okay, that looks fairly handy. I have the 15 already. Do I know this height? And there it is, 15 again. Okay, so let's see, can we get that done? That just goes across here, so that's easy. Project across. And then we need a 15. So we'll go back and get this guy. Can I always draw it just on the page to make sure I'm actually contacting correctly? And you can measure off any of the axes, but I'll do it there. That goes up like that. Now it doesn't go a whole height, so again, let's go back and have a look at our drawing. And that is going to go up by 60. Right, add this to our scale. And you see I could of course added a scale of 45 to the 15 that I have, but bigger it is, the lower margin for error. So that's why I'll always go with the bigger measurement where I can. Now let's pop that in there. So again, we can put this guy in heavy. Okay, try to avoid little double lines like that there. Now, where next? What have we got? What have we got? So, I could come back until this point, but do I know where this point is? That's not super obvious yet. Okay, that looks hard, so let's not do it. What else can I begin to put together? I wouldn't mind knowing where some of these points are. So maybe we might try and see where this line that goes across is. So we know it's 30 up. Right. Let's go do that. .30 scale, and off we go. Now this one is actually slightly trickier than it seems. So we'll measure our 30 up. But of course that line is not there, it's on the surface. So we need to bring it back to the surface. And here's how we do that. We simply project back until we hit the slope. Then at the slope, we can project across. So that is where that line is there. Now what do we know about it? So this edge is along there. It's 40 long, and look, 15 out from the edge. Our good old friend. Now, sometimes you can actually just save yourself a bit of hassle by measuring off the drawing itself. So it's 15 back from the edge. I'm going to measure this here. Actually, I had it up the top even. And here's what we're going to do. In this drawing, these two lines are parallel. And if they're parallel in this, they're parallel in the isometric. So I can actually use that fact to just come from here. See, I actually didn't even need that 15 measurement because I could have come down from here. We'll just double check that again. There we go. Now, you see there's a small bit of error there, and this is really just down to do with our compass. So this is one of the reasons I like to project around where I can, because it makes things, at least you're not adding up errors from different sources. If that 15 was out at the top, it'd be consistently out. So we'll put that line in heavy there. This goes across by 40. I think I have 40 measured here. There it is there. Cross by 40, and that's what we have. All right. So now this is coming together a little bit. So if you're wondering why this is going very blue as we do all our drawing, it is because the sun is setting and the color balance of the different lights is changing. Now, right, diagonal lines are typically awkward, but this one is nice because this line connects from there to the top surface here. See it down again at the bottom, there to there, which in real life is there to there. So that's where it does get a little bit funkier, but if you just think of it as where does it start, where does it end? And there we have that piece. Now, what else can we do? What happens at the bottom here? Now, that's a flat surface there going across. This end projects down to there, but if this is flat and it's going back along this edge, which is awkward, so it's not going at this angle. So we need to think on that a little bit. What do we know about it? It's parallel to this guy. Okay, so let's drop some projections down here, begin to see what we can figure out. Now this back one's going to be pretty obvious. I can see that's going to stop there. That goes down to there. And this one, I'm going to do this as a parallel. Okay, and here's how I know it's a parallel. When I see it in the plan, that's a vertical face, which means the bottom line is parallel to the top line. Is it? No, it's not, because it's a slope. Okay, so look, that's just a weird problem for the moment, and we're going to come back to that one. Again, we'll solve the harder problems along the way. For the moment, though, let's get this little edge. Now, this little edge I do know is part of the surface, so it's going to be parallel to this one. So we'll do our parallels there. There we are. And equally, you see, I could have just connected top to the bottom. There's different ways you can do these things. So we project down like that. I can see it's going to intersect with this, so that's why I didn't go the whole way down. So this is horizontal in real life. It goes back to there till it meets the surface, and then that's heavy. Of course, that's a little rectangle on the top, so it goes back like that, across from here, and we just go back and complete it. Now, what do we have left? There's definitely something going on here, that's for sure. So let's see, can we solve that problem before we go down to our friend down here? That's all one surface. So this is all one surface. What we need to find is the edge along there, the edge inside that, which is just parallel to this, which comes from there. Actually, it's just going to be there to there, really, isn't it? Okay, connect the edges. Now, if you're unsure about this, check your parallels. It should be parallel to this. Yes, it is. Okay, we had the start and the end, but you can do a quick cross-check, and now we have it. Okay, so this final little line on the bottom, all right, now, like I said, it was tempting to think that it'll be parallel to this, but of course it's not, because we can see that it's going off at a different angle. So what do we need to do? Well, if we can't do parallels, we need to do starting and finishing. So let's figure out where this corner here is. Okay, it does straighten out at the back, but if I can find this point, I'm golden. Well, I'm going to come down from here, I'm going to come across from there, and I'm going to see, can I box it off? Well, this might sound a tiny bit complicated. It's actually fairly fast to do. So I know that that edge is down from there, because it's really down from there, but come across, come down. I know that it is on this flat surface, so it's across from that height. And now what I can do is I can send a line back. So that edge, so what I've just done now, I've created this line on the ground. So I still need to figure out where that point is. Well, it's straight down from here. So let's come straight down from this edge to where it meets that point, and there is where this guy joins up to. And now you can see it. That's going to be the line. So of course, that's the bit that's heavy. I'll just finish off the construction line, but that's the bit that's heavy on it. Now, at this stage, we're looking pretty damn good. Let's just check what our lines is. That could be a touch heavier. Just pop it in there. And all of our surfaces seem to be in there. And now we have it. Quite a satisfying little drawing. A little bit tricky on that one. People often get tripped up on it. But you see, we just figured out it's straight down from there. It's crossed down and back across that surface. And then we have it.